Welcome to our channel Learning Math. In this video, we're going to solve a geometry problem for grade 8 about rectangles. Now let's start together. We have a triangle ABC which is right at B, and BM is the median drawn to AC. We should draw the altitude BH to AC. Let's start together drawing our figure. First of all, we have the right triangle ABC as you see in the figure. We have the median BM issued from the vertex B to the midpoint M of the side AC. Note that it's a median in a right triangle, so we can say that BM equals half the hypotenuse AC. So as you see, we marked them equal. BM equals AM equals MC is equal to half the hypotenuse AC. Now let's start drawing the altitude BH. First of all, if you note something, the altitude should be drawn from the vertex B to the side AC. So we should put our set square aligned to the side AC. Well, when we put it aligned to AC as you see and passing through the vertex B, now we can draw the altitude BH as you see. Well, we also have D and E are the orthogonal projections of H on A, B, and on AC respectively. So from H we should draw the orthogonal projections means perpendiculars. Let's start by the first one. The perpendicular from H to AB. So we should put also our set square now aligned to the side AB, and we draw the perpendicular as you see from H. It's here aligned to the side AB. Now we can draw our perpendicular. This is the first orthogonal projection which should be named D. Now let's draw the second from H to the side BC. Now we should put our set square aligned to the side BC. It's an orthogonal projection on BC, so we should put the set square aligned to the side BC. Sure, since it's an orthogonal projection of H, it should be also passing through the point H. Now we can draw our perpendicular. Well, as you see here, we name them D and E. Here are our orthogonal projections. Well, now in part A, show that DE equals HB. If we think about it, show that DE equals HB. Before solving any problem in geometry, we should think what each line represents here. When they ask us to prove that two lines are equal or perpendicular, we should think what do they represent in the figure. If you note that BH is a diagonal in what? In a rectangle. Yes? And DE is also, if we join it, it will be the second diagonal. Two diagonals in a rectangle should be equal. They are asking us to prove that DE is equal to BH, as if they are asking us indirectly to prove that here we have a rectangle BEHD. Well, how to prove it rectangle first? If you note here, how many right angles are we having? 1, 2, 3. 3 right angles form a rectangle, give us rectangle. So we can start by them. We have A, B, C salient. We should explain why they are 90. The first one is 90 degrees. It's an angle of the right triangle ABC. And also we have HDB salient equals HEB salient equal 90 degrees. Since we have orthogonal projections, D and E are the orthogonal projections of H on A, B, and BC respectively. Well, we are having right now how many right angles? 1, 2, 3. Then we can say that we have a rectangle, so HEDB is a rectangle. Now we can directly say that DE is equal to HB. They are diagonals of this rectangle, so since the diagonals of a rectangle are equal. Now let's start by part B. They are asking us, show that the angles MAB salient. If we look at it, MAB salient. This angle, we need to prove it equal. So the angle MAB salient, this angle. They are asking us to prove it equal to the angle MBA salient. Here we have BA salient. We need it equal to this angle. If you note something, we have marked them equal sides since median equals half hypotenuse. Two sides are equal. Shouldn't they give us an isosceles triangle? Also, we need to prove that MBC salient, here if you look at it, MBC salient, this angle should be equal to the angle MCB salient. Also here we have two equal sides that should give us an isosceles triangle. Now how to prove it? First of all, we should keep in mind the rule in a right triangle, the median is equal to half the hypotenuse. So here we can say that the median BM is equal to half the hypotenuse AC, so it's equal to AM and equal to MC equal half AC. Then both triangles MAB and MBC are isosceles at M. Well, now we can say that the angles MBC salient and MCB salient are equal as base angles, and also the angles MAB salient and MBA salient are equal as base angles in these triangles. Now show that DE is perpendicular to MB, something which is very important. Before starting by this part, we need to understand a rule. As you see here, we have an angle. I have produced the first side of this angle and then drawn a perpendicular on it. Well, if you note, I have produced or prolonged the second side of this angle and also drawn a perpendicular on it. If you know something, we have in this figure now two triangles, two right triangles. These two angles are equal to 90 degrees. We also have in this figure a shape X, then we have vertically opposite angles that are equal. Now can't we say that the third angle here is equal to this third angle? Here we can conclude a rule. These two angles are equal since they are perpendicular side by side. If we refer back, how did we draw them? The first side of this angle we have drawn a perpendicular on it, and the second side of this angle we have drawn a perpendicular of it. These two perpendiculars form between them an angle. So these two angles are then equal since they are perpendicular side by side. We're going to use this rule in order to prove our part. So here we need to show that the sides D, E and BM are perpendicular. First of all, if you note, we have here a 90 degree. Well, can't we say that the sum of the angles D, E, B salient, this angle, plus this angle here, which is D, E, H salient, this sum is equal to 90 degrees? Well, if you note something else, we have the diagonals of a rectangle are equal and bisect each other. Now can't we say that IH is equal to IE? Well, two equal sides give us an isosceles triangle. Then the base angles in this isosceles triangle are equal. So we can say that the angles IEH salient and IHE salient are equal as base angles in this triangle. Why are we doing this? Note that we have reached to this angle, but the side IH is given since we have BH is an altitude, so it's perpendicular to the side AC. Well, it's a side of the angle IHE salient. Now what about the side HE, the second side? Isn't it also perpendicular to BC? Well, now we have the angle formed between these two sides is equal to the angle IHE salient. So we can say that IHE salient is equal to the angle HCB salient. They are perpendicular side by side. Well, something else. In the previous part, we have just proved that MCB salient is equal to the angle MBC salient since we had an isosceles triangle. Well, now we have reached that these two angles are equal. So we can say that the angle IEH salient is equal to the angle which is MBC C salient. Now can't we say that since the sum of these two angles is 90 degrees, can't we conclude that the sum of these two angles is 90 degrees? Therefore, we can say that the angle KBE salient plus the angle KEB salient is equal to 90 degrees. Or we can say instead of KBE salient, MBC salient, it's the same angle, plus this angle which is here, which is here, IEH salient. Well, we have the we have this angle which is DEB salient. Now we have the sum of these two angles is 90 degrees. Note that here we have a triangle which is KBE. Can't we say that the sum of angles in a triangle is 180 degrees? Then what about the angle BKE salient? Isn't it 180 degrees minus 90, which is the sum of these two angles? So what remains for it? 90 degrees. Therefore, we can say that the sides DE and BM are perpendicular to each other. Thank you for watching. If you enjoyed this video, please like, share and subscribe for the continuity of our channel to support you by more and more information with a great appreciation for your support. Thank you.